Good. If you guys can have a seat, we'll get going. I want to thank everyone for coming this morning. My name is Michael Sutton. I'm the director of iDefense Labs. iDefense Labs is the research arm of REcon. We're tasked with researching and discovering vulnerabilities. So the purpose of today's talk is to just share with you some of the things that we're doing. In the work that we do, we create some tools, some methodologies. When we get them to a certain point, we'll give them out as open source tools so that you guys can use them, give us feedback, hopefully make them better. So I'll share some of that research with you. But before I begin, I also want to thank Hugo and his team for putting on a fantastic conference. You guys fill a really important niche in the industry, and I'm sure it's a lot of hard work to put this on, but I definitely want you guys to know that your efforts are appreciated. So what we're going to cover today, start out with just some background, what fuzzing is. I'm sure everyone's familiar with it to some level, but just to set a baseline. We're going to talk about some different tools that do different types of fuzzing, but really, regardless of the type of fuzzing you're doing, you still follow the same basic approaches. So we'll talk about the different steps or the stages that you go through, look at things that can be fuzzed, and then get into the more interesting stuff. Okay, that's the theory, but how do we automate this? How do we actually put it into practice? And then I'll demonstrate some tools that we put together. These are all open source tools. Some of them are already out there on the labs.idefense.com webpage. FileFuzz and Comrade are both out there. WebFuzz is actually just still a QA thing. We're still playing with it, but I gave it to Matthew, and I think he's going to put it up on the website so that you guys can have access to it. And by all means, the only thing I ask from you guys is make it better. Give me some feedback. Tell us ways that we can improve the things. And it's open source, so build on it and just give it back to the world. Starting off with some background. Really two basic approaches to vulnerability discovery. You have white box, you have black box. What's the difference? White box, you know everything. Black box, you don't. White box, you have the source code, you have access to the developers. Black box, you have the same thing that any other end user would have. People often assume that one approach or the other is better. Not true. I mean, they're just different approaches, different ways of doing things. You're going to find different issues by taking different approaches. White box obviously is a static approach. You're looking at something at a given point in time. An advantage of it is that you have full code coverage because you have the code. You can see absolutely everything. But again, because that's static, you're not necessarily looking at it in a real world scenario. How is this actually going to be used? Is it dependent on other, perhaps proprietary compiled libraries? You're not taking those things into account. It's not good, bad, it's just one approach. I like to use analogies in describing things. So in describing vulnerability discovery, the analogy I want to use is breaking into a house. So in a white box approach, you have full knowledge. You would have the blueprints for that house. You know the complete layout, you know the materials that were used, you know everything about it. But you don't know the real world scenario. You may know that that window is vulnerable and it's a great way to get into that house, but you don't know that the owner is sitting in the living room with a shotgun ready to blow your head off because he's protecting his house. The other side, the flip side of the coin, black box. Again, it just means that you have the same level of access as any end user. So you don't have the source code, you can't talk to the developers, you probably have some basic end user documentation, and you have access to the compiled application, assuming that that's what it is. You can kind of split that into two subcategories, reverse engineering and fuzzing. Reverse engineering is surgical, it's stealthy, it's sexy. You need a high degree of skill in order to do it. Fuzzing, the opposite. It's ugly, it's inefficient, it's brute force, but it works. It's effective. One of the points that I want to make today is that I think fuzzing is a good approach for a broader audience than currently uses it. Because it's simple and it can be automated, you don't need a high skill level to be able to do it. It can be done by people who aren't security experts. It can be done by your QA guys, by your developers, to find the vulnerabilities before they get into the production code, which is the problem. That's generally where we find vulnerabilities today, is when things are actually out there in production. Another advantage is that it's dynamic. You actually using and seeing the tool as it was intended to be used. Now, going back to my analogy, what would be the reverse engineering approach to breaking into a house? Picking the lock. It's high skill, you need the right tools, you need to know what you're doing, take some practice. Not everybody can do it. What's the fuzzing approach to getting into that house? Taking the house out. I don't care. We're going in. What is fuzzing? I looked up a fancy Wikipedia definition of it. I think that's a great definition. But from my perspective, it's real simple. You're just taking unexpected input to see what the unexpected results are. You're trying to say to yourself, what are the things that the developer may not have taken into account when he developed this application? What air handling routines might not be present there? And can I make it cause an anomalous condition, and perhaps can that condition be exploited? Going back to our house analogy, what would be an unexpected input breaking into that house? I wouldn't expect that. Although it would be a way to get into the house. So who should fuzz? This is the point that I was starting to make earlier. This is kind of the message that I want to send out today. Today vulnerabilities are discovered primarily by security researchers. I don't feel that has to be the case. I think it can be a much broader audience than that, and I think that the goal of any company or organization that develops software should be to move that vulnerability discovery as early in the development life cycle as possible. And one way to do that is to place reliance on other individuals to find those vulnerabilities. It doesn't have to be done by the security researchers. It can be done by the QA teams. It can be done by the developers. The downside to the current approach, it's reactive. The software is already out there, it's in production, and if a vulnerability is found, people are vulnerable. We can be more proactive by moving that earlier in the life cycle. Current life cycle, we design an application. It's, the analysts, they sit down with the end users, they say, what do you want this thing to do? It gets handed off to the development team, they say, no problem, we'll put that together for you. Goes to the QA team, and we're not saying to the QA team, make sure that this thing is secure, we're saying make sure it works, make sure it's functional, make sure it doesn't break. And finally, it goes out the door, and it's in production. Well, today, when we do most of our research, such as fuzzing or reverse engineering, or any approach you want to take to vulnerability discovery, with the possible exception of source code review, it's the security researchers finding that vulnerability in production. We need to back it up and have the QA teams doing the work to find it, having the development teams doing it. And I feel that fuzzing is a good approach to that because of the fact that a great deal of it can be automated, and if you can provide the developers and the QA teams with the appropriate tools, that they don't need to be the experts. You can bring the security researchers in later. If they find a crash and they say, I don't know if this is good, bad, or indifferent, then the researcher can come in and say, yes, this is an exploitable condition. But even so, if you're fuzzing your application, you're finding all sorts of crashes. I mean, who cares if it's exploitable? There's obviously a problem with your coding if it starts crashing all over the place. Just an interesting example of what fuzzing is and what it can do. One thing that we are tasked with is researching a lot of vulnerabilities. Those aren't just original vulnerabilities or vulnerabilities that we're responsible for or that come into us through our contributor program, but also just vulnerabilities that are out there in the world. And it's a rare scenario that we get insight into how somebody may have actually uncovered a vulnerability. This was just one interesting example that we came across where we got some interesting insight that suggested that the MS0601 vulnerability, which is a WMF vulnerability, was probably found due to fuzzing, which isn't surprising. It's a file format vulnerability. I think that's probably how most of those things are found. Many of you are probably familiar with this particular issue because it ruined Christmas vacation for a lot of people. Came out right around Christmas time, and I'm sure you got a call from your boss, put the presents down, time to go to work. And one of my colleagues, Greg McManus, got a hold of the exploit that was in circulation and decided that he wanted to find the original image that was used for that. I said, Greg, how the heck are you going to do that? That's kind of crazy. Because any file format vulnerability, really all it is it's a legitimate file that's mangled in some way, and the program interpreting that file doesn't know how to handle it, so it crashes and can be exploited. So in this case, because it was an image, it was just a particular image file that was mangled and that led to the vulnerability. And when Greg looked at it, he noticed that there were human-readable strings within the binary, but they were things that weren't typical words. It's in that first line where it says J and K equals. Like, they just seem to be terms, references. What he also found out was that at that time, Google didn't understand what a WMF file was. It didn't know that that was an image file, so it indexed it as though it was a text document. So he realized that he could actually use Google to search for strings that were within the file. And so that allowed him to try to find the original file. The problem that he ran into was that he was searching for the wrong words. Like, I have an example, catase to kinase. So he was searching for the word catase because that was the word, or at least what he thought was a string, within the file. What he realized later on is that, this thing had been mangled, and so it wasn't, the original word wasn't catase, it was kinase, which was an enzyme. And eventually he realized that these were all just a bunch of scientific terms. And so once he sort of figured out what the actual word was for, he was able to search, and he did find the original image, and that was it for this particular exploit. Looks like it was maybe a slide from a presentation, maybe something, something from a university, something like that. And when he dipped that against the actual exploit, he saw that it looked like indeed probably fuzzing was used. They were just blocks of strings that had been overwritten with, single characters repeated. So just an interesting example that, probably fuzzing was used for this. And again, I think most file format vulnerabilities probably are discovered that way, so not too shocking. I mentioned that when we're fuzzing, you can fuzz anything. I mean, a computer's a really simple thing. It takes input, processes it, provides output. Anything that takes input can be fuzzed. So any kind of application, but no matter what you're doing, it's going to follow the same basic phases. The first thing you got to do is identify your target. Generally, that's a pretty simple process. That's why you're fuzzing. But as we get into it, I'll talk about some unique aspects of that. Second thing, you got to identify your inputs. I put 6 steps here, and I consider 2 of them to be kind of extra important, and this is one of those, identifying your inputs, because you really have to think broad when you're thinking about your inputs. Sometimes inputs are really obvious, but often they're not. I think a web application is a great example of that. A really obvious input in a web application is the web form itself. It's designed for input, but you can't think of it that way. Anything that you send is an input. So when you're requesting a web page, you're not just sending the data in that web form. You're sending headers, cookies, hidden fields, all kinds of stuff. That's all input. It can all be fuzzed, may lead to an anomalous condition. So you have to think broad when you think of inputs. Then generate your fuzz data. And you want to be smart about it. You want to say, okay, what does this thing expect? What might it not expect? If the field is 10 characters, maybe I want to give it more than 10 characters, less than 10 characters. If it's expecting numerical values, maybe I want to give it character values. If you're dealing with binary files, you're going to approach it in a different way than ASCII text files. You want to execute that data, and depending upon what you're fuzzing, maybe that means sending your data to a web application, or maybe it means launching a console application. Then monitor for exceptions. I said that there were 2 phases that I think you should pay particular attention to. Monitor for exceptions is definitely the other one. And the reason I say it's extra important is because I think a lot of people leave this out. And fuzzing is a painful experience without this. Think of you're sending 100,000 requests to some application, and computers are great for fuzzing because they do all the work for you. So you start up your fuzzer, you go to bed, you wake up in the morning, the things crash. Big deal. You don't know which of those 100,000 things led to the exception. So you're no further ahead than you were before you started, except you know that it might be vulnerable. So it's really important that if you're building a fuzzer, you're building some piece in there to, after you send or as you send an input, monitor it to see what the results are. And there's many different ways that you can look for results. It's not simply a debugger. I'll talk about some of that later. You just want to be looking for anomalous conditions and knowing which input may cause that. And then lastly, you want to determine potential exploitability. This is the one step that's really hard to automate, and so, if you have your QA guys, your dev guys doing fuzzing, this is where you may need to bring in the security guys, because you can build a tool that sort of automates all those first 5 steps, but just because you found a crash, you don't necessarily know if it's a security issue. But again, I still think that's very realistic to have the guys running the tools, and then they can bring somebody in to say, you know, what does this mean? What kinds of things can you fuzz? This is by no means an extensive list. It's just common things that I think people tend to fuzz, and some of the tools that people use for that. The ones that we'll look at today are Web Fuzz, File Fuzz, and ComRaider. Anything that takes input can be fuzzed. I classify the approaches to fuzzing in 3 different categories: test cases, brute force fuzzing, and intelligent fuzzing. So the first one is test cases. I don't actually personally really consider a test case to be true fuzzing, because I think of fuzzing as dynamically generated input, whereas a test case isn't that. A test case, a great example that many people are familiar with, would be the Protos test suite. Back in, I think, probably 2001, 2002, there was Oulu, I think it is, a university in Finland, found a ton of SNMP vulnerabilities. And what they'd done was really basic, really smart. They looked at the spec for SNMP, created tens of thousands of test cases that were legitimate requests, but that they didn't think that, you know, the various applications would have implemented handlers for. And sure enough, they found all kinds of crashes. And the beauty to that was a lot of work up front to build all these test cases, but then they could run it against dozens and dozens and dozens of applications. So I mean, it's great. You get good consistency. You can test all applications to the same level. Downside is that it's pretty time-consuming and it's static. Like, you can send one test case and get nothing, and maybe if you just changed one little byte, you would have had a different result. Brute force fuzzing is really simple. It's the most basic type of fuzzing. In this way, you're just taking a legitimate input, be it a file, be it a network packet, whatever the case is, and you're mangling it in some way. You don't need any upfront knowledge of the structure of that format, because you already have a legitimate file to deal with. It's really inefficient because you're probably going to send a lot of requests that are just not meaningful, but very simple to start, very easy to do, and computers do the work for us, so we don't need to be that efficient. In some fuzzing approaches, it works very well. File format fuzzing, I think it is a good approach, and that's what we use for one of the tools that we use. Intelligent fuzzing, here you're not starting, and these aren't industry terms by any stretch, these are just terms that we use. Intelligent fuzzing, you're not starting with a known good input, you're creating a template to explain to the fuzzer what a known good input is. Like Spike is a tool that many people are familiar with, but that would be an example of that. You build a file that says, okay, this is what a legitimate packet would look like, but in here, instead of making some things constants, make them variables, and I want you to fuzz those pieces of it. So it's more efficient because you're fuzzing the pieces that are more likely to have the issues. A little more time consuming though, because you got to build those templates up front, but for some types of fuzzing, in my opinion, is probably a better approach. The first tool, this is one that we released last year, File Fuzz. It's a file format fuzzer. We're seeing all kinds of file format vulnerabilities. They're all over the place. We had the GDI thing a couple of years, or JPEG GDI thing that a couple of years ago that kind of sort of kicked off an interest in it. WMF was that. This last Microsoft Black Tuesday, we had a bunch of file format issues in there. That Word issue that was being hacked was that. Again, we always follow the same basic phases when we're doing our fuzzing, but there are unique aspects of it depending upon what it is that you're targeting. So, identifying our target, a unique aspect of file format fuzzing is that your target, where the vulnerability is going to be the application, but you're probably going to be choosing a file type. So, let's use WMF as an example. It's an image. But it can be rendered by many different things. By default, on a Windows box, it's Microsoft Picture and Fax Viewer that will open a WMF file. But Internet Explorer could handle it, Paint could handle it, all sorts of third-party products can handle it. So you're probably going to be picking a file format, and then you're going to fuzz a whole bunch of different applications, which is nice. You get a bunch of freebies. When you're picking your targets, look at vendor histories. History doesn't lie. If a vendor has a whole bunch of vulnerabilities in one area, it probably has a whole bunch of vulnerabilities in another area. Because those vulnerabilities aren't there by chance. It's probably due to poor coding practices, poor QA, history repeats itself. What are the more high-risk targets? Well, certainly in a Windows environment, anything that is a default handler for a file type is a higher risk target because Windows is very friendly. You just point and click on things. So if you find a vulnerability in the application that is the default handler for a particular file format, that's a much higher risk than something where you actually have to social engineer the user into opening it in a specific application. This makes sense. With file formats, as with anything else, you could have proprietary, you could have open formats. If the formats are open, you have a lot of knowledge about it because there's documentation on it. But just because something's proprietary doesn't mean that there isn't documentation. Google is your friend. Don't start from scratch. Don't try to reverse engineer some file format. I guarantee you that if you want to figure it out, somebody else has tried as well. That's a good place to start. The site that I listed there, wotsit.org, wotsit.org, really good resource for file formats. It's a whole bunch of official and unofficial documentation on different file formats. Very helpful place to start. Depending upon if you're looking at binary files versus text files, you're going to take a different approach. With binary files, you typically want to figure out what portion is my header, what portion is my data. In my experience, a lot of the vulnerabilities you're going to find are in the header. So even if I know nothing about a file, a binary file, I probably won't fuzz the whole thing. I might take just the first 200 bytes, arbitrary number, because I figure, that's probably where the header is. And that way I can fuzz it more and get more done because I don't have to run through the whole file. Text files, things like INIs, typically the structure of it is just a name-value pair, and typically it's the value portion of that you're going to find problems in because you're going to get things like overflows. File fuzz takes this concept of breadth versus depth, and what I mean by that is you see in the Xcode there. If it shows up for you on the screen, there's some red F's, like a D-word value, D-word value of all F's, that's just slowly moving across the file. Like when I'm starting with something, I usually start with breadth and then I go for depth. The reason I do that is when I go for breadth, I'll see exceptions throughout. And those are interesting spots that I want to come back to. But what I won't know necessarily is, do I have any influence over that part? Because when I get a crash, I don't see my fuzz data in any of the registers. Then, when I go for depth, so I take a particular location and I stay there, but I try a bunch of different values, then if I start getting crashes in different places, or I get different values in the registers when that crashes, even if I don't have direct control, even if I can't see my actual fuzz data in the registers, clearly I have some sort of influence. If I have no influence, it's probably going to be a lot harder to exploit. Text files, as I mentioned, is probably the value portion of the name value pair that you want to go after. File fuzz can fuzz anything in a Windows environment so long as you could launch that from a command line. And how do you figure out what the proper arguments are? Everything's hidden away in the registry somewhere, as everything is in Windows. But a really simple way to find it, for the most part, about 90% of the time, is within Windows Explorer. You just go to Tools, Folder Options, File Types, that's the window you get that I'm sure you've all seen. So that's showing you all of your default handlers, like what applications are going to handle particular file types. With WMF, if we go into the Advanced button, we get this window. Windows has this concept of actions. In our case, we just want to know what opens WMF file. If we were to click on Edit, we'd get that screen. And the important piece of that screen that we're looking for is the application used to perform action line, because that's showing us the actual command line argument that's used to launch it. And sometimes it's not very intuitive, like Windows Picture and Fax Viewer is a good example. That's not an actual executable application, it's a DLL, and Run32 DLL is used to launch it. So if I was just guessing where the application was, I might not think to be looking for that. And it'll also tell you if there's certain flags that need to be passed or things like that. It's a really simple way to just figure it out quickly. Monitoring for exceptions, I said this is really important. And you can do simple things. You could just fuzz something, and if you had nothing better to do in your life, you could just sit there and watch the screen. And maybe an error message would pop up, maybe it was blue screen, I don't know. Obviously not a very efficient way to do it. You can look at things like event logs or any kind of logs, application logs as well. A big downside to that is anytime you're monitoring and your fuzzing are separated, they're not tied together in some way, how do you know what input caused what exception? You can use timestamps, but again, not a super way to do it. Debuggers are definitely a great way to do it. Although in file format fuzzing, one problem we have is that by design, we're launching something, killing it, launching something, killing it. So I can't manually attach a debugger because it's only going to work the first time. So the simple answer to that is we use a debugging API and build that into the fuzzer so that it is attaching the debugger each time. But debuggers are important because that way you're going to see both handled and unhandled exceptions, which you're not necessarily going to see handled exceptions with some of the other approaches. Executing that file is just simply launching the file. So for the monitoring piece for this is actually written by Pedro, who's sitting back there. He'll be up this afternoon. He used libdasm, and that within the box, that's showing some sample output. So we're just looking at some simple things so that we can run the fuzzer, and then we can scan all these crashes and kind of visually make a determination on which ones we want to go after. So we capture some simple stuff like where did it crash, what was the actual exception, what are the operands that occurred there, what are in the registers. So I can see simple things that I can be like, that's not ever going to be exploitable, I'm going to ignore that, or yeah, that requires some further research. To actually interpret that, you do need some disassembly debugging skills, and so again, your QA guys and your dev guys aren't necessarily going to have that, but there's no reason that they can't run these tools, and if they find a ton of exceptions, then have somebody else take a look at it. What kinds of things can you find? Same vulnerabilities you could find using any other approach. So we'll just run through a simple demo. This is a video file, and I'll just take it out to stop it and make some comments. So the way it's set up, you can select, again, this is brute force, so you're selecting a known good file, and then you're mangling it. So you can manually select your source file, your target directory, and all that. There's also that drop-down is just some built-in audits that if you select one of those, it'll just fill in everything for you. And I tried to use files that are by default on a particular, on a Windows operating system so that it would still work that way. The one that I selected for here is an AST file. I was just using my computer one day and I realized that I had actually WordPerfect installed, and AST is some file associated with that. And I had never even used my WordPerfect. It just came like free with the laptop. I didn't know why it was there. And I thought, hey, I've never heard anyone look for bugs in this product, so I'll take a look. And there are all kinds of crashes. So if you're looking for some low-hanging fruit, that's probably a good one to take a look at. So the first thing I did, I was in the Create tab. And basically there, I'm taking that known good file, so I'm saying, here's a sample AST file, and this is what I want you to do with it. I want you to overwrite these bytes. In this case, sorry, I didn't stop it early enough, but I was going for breadth, so I said from 0 to 11 bytes, or 0 to 10 bytes, just overwrite it with a D-word value of all C's. And I just picked C's because it's something easy to see in the registers. So once I've created those files, I've created my dozen files, then I move over to the execute tab, and I just tell it to run. There's a couple of things, script file extensions, exclude target directory. In building this, I found some applications had weird things, like Windows address book, I had to strip off the file extension, so I just added some options to do that. All I'm telling it is, launch this application, use those flags, it needs like a / QT flag or something, and just run through file 0 to 11. And only allow a timeout of 1 second. So all that it's doing, it's really simple. It's just launching WordPerfect with this file and killing it, launching it, killing it, launching and killing it. But as it's doing that, it's attaching a debugger and looking for exceptions. And you can see, like, I got a ton of exceptions, and I can see my data in the registers. And again, that's why we picked those things, so you can kind of quickly see, like I can see my data there, and as you scroll down, I know it's my data because you can actually see it kind of walking in, like it's a couple of bytes, and it's 4 bytes, 6 bytes, whatever, and so I can see that those are maybe things that I want to take a look at. Again, really simple concept, not a whole lot to it, but helps you to automate that type of fuzzing. Also, the depth demo is really very same thing. Again, I start with bread, and you can see when I did bread, I found maybe 5 or 6 exceptions there, so I can see spots where there's maybe an issue, and then I might go for depth to see what kind of control. In this case, it's pretty obvious that I have some form of control because I can actually see my data in the register, so I probably wouldn't go to that. And just in the interest of time, I'll just skip over that one. The next application that we put together is WebFuzz. This is the one that's still in QA, but I gave it to Matthew to put up on the site so you guys have a copy of it. Again, if you want to play with it, just give me feedback. I certainly appreciate that. The inspiration for this was I was looking for just something, a tool that would allow me to do fuzzing on just a single web page. There were things that I wanted to mess with, and I didn't find anything that I was looking for. Ultimately, I found actually a really good tool. It was Spy Fuzzer, which is in the Spy Dynamics Web Inspect product. They have a whole bunch of little utilities in there, and this was one of them. The only downside was it was a commercial product, and in order to get this one little utility, I would have had to acquire the whole thing. So I took a look at it, and it kind of inspired this. I mean, there's this fancier and nicer, but mine met my needs. So again, same phases that we go through. We want to identify our target. And in this case, one unique thing is your target is going to be a web application, but keep in mind that web application runs on a server. So it's quite possible that in looking for a vulnerability application, you could uncover an issue in the server itself. High-risk targets, obviously, those that are out there more often. What are easy ways to find that? Look at the counters on the download sites, download.com and things like that. It'll tell you how many times something's been downloaded. Or just use Google. If you can find sort of a unique search that'll tell you what version of an application is running, and Johnny I Hack Stuff has a bunch of those kinds of things. You can see how many hits you get from Google to know, is this something that, if there's a vulnerability in it, is going to affect a lot of people. Identifying your inputs, I already used this example earlier on. Think broad. Don't think of just basic, form data. You want anything that you're sending to that server is potentially an input. And how do you find those things? Well, you can manually surf around for them. You can use proxies to see what your actual request is. Live HTTP headers is a really useful Firefox extension. I always use that. It just allows you to see your raw requests and the raw responses. And it's just an open source extension or add-on to Firefox. If you want to do a thorough audit, though, obviously you have to use a spider or something that's going to give you full coverage of that site so that you can see all inputs. WebFuzz takes the intelligent fuzzing approach. I said, intelligent fuzzing, I'm not starting with a known good packet, so I'm not like taking a data packet and just mangling it. I'm telling WebFuzz this is a legitimate request to that server, and within that request, here are the areas where there are fuzz variables that I want you to hit. So if you see in the web template piece, there's a bunch of items in red. And so those are the areas where I'm saying, this is where I want you to fuzz. A basic request is like, get. And so I'm saying, try different methods. Try put, try post, things like that. See if it handles those things. Traversal. Try some directory traversal things. .. In the arguments that are being passed, look for SQL injection, look for cross-site scripting. This is just an example. I'm not saying that it would, you would be looking for everything all in one request. And in the host name, try an overflow. Just start sending a whole bunch of data. But I basically said, what are the kinds of things, what are the kinds of vulnerabilities that we typically find in a web application, and then broke those down into categories, and I just refer to those as fuzz variables. Those are the classes there, and you can implement many others. Again, it's an open source tool. Just take it, expand on it. It's just an idea. The monitoring for exceptions piece is going to be a little bit different in this scenario because we're taking a different approach. We're not launching and killing a web application. It's going to keep running, and we're just going to keep firing requests, but we want to see what happens. There's different things that we can use. One thing that's really helpful is the status codes that you get back that are, just built into web traffic. And so if I get back a 200 status code, I know that page was rendered legitimately. If I get some other weird status codes, maybe that tells me that I'm causing a problem that I want to look into. A debugger is definitely a good thing. And in this case, you can just manually attach a debugger to the web application. and see if you get any handled and unhandled exceptions that way. Lastly, I build a timeout in there in case the request gets hung. I can just break that connection off. Web fuzzing is actually, you don't need a very high skill set. Because you don't need things like debugging and disassembling. Like anyone who's a developer of web applications has all those skills. They know what HTTP is, they know what HTML is. So I think this is a really legitimate approach for your developers and your QA team to use tools that are fuzzing the web applications. And it's same deal. What vulnerabilities can you find? Same things you can find with any other approach. Looking at a demo. So I'll just sort of comment on the basic layout first. All it is, top window, I realize it's hard for you guys to see, so I'll try to just explain it for you. The top window that's where you're building your request. It has a default request of like what a standard Internet Explorer browser would send to a thing. It's just a starting point for you to build your request. In the second window, it's going to be a table of the responses. And then in the last window will be detail for an individual response. At the very top, you're just giving it the host and the port and the timeout. So the first thing I do is I'm just testing the connectivity. So I'm just making a request to a known good site, in this case idevents.com. I just want to make sure things are working. No fuzzing taking place. I'm just sending a regular request, and I get back my 200 status. So I know that, okay, everything's working. I asked for my web page, I got it back. At the bottom, I capture the raw request, the raw response, and then just an HTML interpreted version of the response. Because you can get quick visual clues. For example, SQL injection, you'll often get error messages actually within the code. So you want to see that in the response. What I've switched to now, there's a virtual machine running in the background, because I just wanted to set up a really simple example. So what did I use? Simple web server. That seems logical. There's just a very basic buffer overflow that's very obvious, and so it makes for a good example. So all I'm doing now is I'm just launching that web server in the background. So think of this as two different boxes, an attacker and a target. Then I'm just going to, again, test the connection, but this time to the web server that was set up, just to make sure that it's running. And I want to, hopefully if all's well, I'll get my 200 response, which I get. Now I can actually do the fuzzing. So I want to take that basic request, and I want to add some variables to it so that the application knows where to fuzz. Right there, that's just, I just added all the different headers in there so that if you want to manually build your request, you can, and you don't have to remember all the different things. It has nothing to do with the fuzzing. It's just to help you in your activities. And so I'll add, I think I added a refer header. Again, just for demonstration purposes. We're not actually fuzzing that particular header. But then the second piece is, now I want to add my fuzz variables. In this case, so it says add fuzz type, I'm going to add, I'm going to look for an overflow, because I know there's an overflow. And so it's going to add that. In this case, it requires some parameters from you, because it's not a static thing. It's not just going to send a hard-coded overflow. So the three things it's going to ask you for is what text do you want me to send, how big is the chunk going to be, and how many chunks. So in this case, I think we're going to send a bunch of A's, 25 A's at a time in 12 chunks. So 25 A's, 50 A's, 75 A's. So we send that, fires off the request, and then sure enough, as we knew would happen, it causes a crash. Now keep in mind, this is really low-hanging fruit. This is a really obvious example, and you're going to be very lucky if you ever run across something like this. But just to demonstrate, EIP is overwritten with the fuzz data that we'd sent. So, simple example of how fuzzing can be used against web applications. The last example tool is ComWriter. This was written by David Zimmer. It's a fantastic tool, and I can brag about it because I didn't write it. He's a far better programmer than I'll ever be, and he did a really, really good job of putting together a very user-friendly application. And this is absolutely a fuzzer that can be used by people who are not necessarily security professionals. My mom could use this and find vulnerabilities. She's a pretty good hacker. Again, going through those same phases, identifying your target. The purpose of COM Radar is to fuzz COM objects, specifically ActiveX controls. More specifically, the idea was to find those controls which are marked as safe for scripting, because those are the sorts of things that can be accessed by a website through a browser. So there's a fairly high risk. If you've installed and trusted an ActiveX control that can be called by a third-party website, and there's some sort of vulnerability in it, you're opening yourself up to attack. So again, it's focused on client-side attacks and specifically the ActiveX controls within them. It determines for you if it thinks something is fuzzable. So it's going to help you find the ActiveX controls on your system. And then it's going to say, okay, I think this one is a good one to fuzz or not a good one to fuzz. What's it doing to do that? Well, it's looking at the methods that are exposed by that particular control, and it's looking at the inputs to it. So it's not going to fuzz something that takes like a bool, because it's true-false. Like, what are you going to fuzz? But it is going to fuzz something that's taking integers and longs and things like that as input. What it does is, I thought this was a smart idea on David's part, so he creates a WSF file, a Windows script file, and then launches that within Windows script host to hit that particular control. And then as far as monitoring for exceptions, similar to file fuzz, this is launching and killing, launching and killing, launching and killing. So you don't have the option of just manually attaching a debugger. So same idea, he built his own debugger in there, used the debugging API, and just keeps attaching to it. He has a hard-coded timeout in there of 8 seconds, just so that you don't eat up memory by continually launching all of these things. He also built in a window logger, just as some additional information for you. So he was finding when he was fuzzing these things, there were a lot of pop-up windows with error messages, and so he's also captured that so that when you go through your output, you can see that, because obviously that could be an indication of an area you want to take a look at. Same kind of skill sets are needed for this as the file format fuzzing. I mean, if you want to actually say, is this crash exploitable, you're going to need the disassembly and debugging, but not necessary just to run it and see if you get crashes. Again, it's a really user-friendly application. Another very cool feature that he built into it was a distributed auditing capability. I think it's a great idea for any security tool that you're building in there. So basically, you can set up a MySQL server, and different people could be using COM Radar, and the results that they find, they can then upload that to the MySQL server. Next guy comes online, he wants to audit his entire box. Before he does that, he downloads your results, and he can see, oh, okay, well, I have like 1,000, ActiveX controls that I could audit, but I can see my buddy over here has already audited 500 of those, so I'm just going to cut those out right now. So, great way if you want to take a team approach to doing the work. It's built right into the application for you. He does more logging than I have done in file fuzz. He gathers a lot of stuff that we'll see when we look at the demo. So looking at the demo here, it's a Windows-based GUI application. I'll just stop it right there. So just some basic options that you can set. The one that's grayed out there is the distributed auditing capability, and the only reason it's grayed out is because he hasn't set up like the DSN and stuff to tell it where the SQL server is. So if that was done, you would be able to see all that. But again, very easy. You can tell it which debugger you're using, so that like when you get your results, you can double click on things and actually launch that in the debugger. He started, it literally is wizard driven to the extent where it has a picture of a wizard. How do you find those ActiveX controls on your machine? It gives you a lot of different options here. You could just specifically select an ActiveX control that you want to target. You can scan a directory. You can just give it the GUID of that control. You can say only find those things that are accessible in IE. You could use an old audit, and again, the one that's grayed out is the distributed auditing capability. In our case, we're just going to use an example file, which is just a test that was built that's a known vulnerable control. And you can see it has 4 methods within it. And so you just tell it, build my fuzz files. And in this case, it built 23 fuzz files. Why 23? Well, those methods, based on the arguments that they received, file fuzz figured out 23 different ways that it could fuzz. And so then once we started, it's just launching those WSF files and just attaching that debugger, launching it and letting it die, launching it and letting it die, or killing it if need be. And you can see right away, it's found exceptions, and it's also recorded some of those pop-up window error messages. And so I'm not going to let it run all the way. What I'll do is just pause it and then take a look at one of the exceptions. And again, for this example, I'm using really low-hanging fruit. And you can see right away, I mean, the address tells you that, yeah, he was overwritten, but he captures a lot of good data. I can see where the crash occurred. I can see that my SDH chain was overwritten. I can see the values in my registers. At the bottom, when it scrolls down, you see that the stack was overwritten. So really simple, really easy output. Again, the debugger is actually attached to that as well, so that you can double click on things and launch them in, if you're using Ollie or whatever. I didn't add that into the demo, but this is just looking at a different exception. And you can see, again, just a very low-hanging fruit. I mean, again, you're probably not going to be this lucky and find something that easy, but demonstrates the idea. So, what are some things that we could do to our tools to further them, or if you're building things, where can you take it from here? We've taken the approach of building specific tools for specific problems. That works, but it's not the most efficient way to do it. I think developing a fuzzing framework and using that to build your tools is a much better concept. Peach Fuzz is an example of a fuzzing framework. Because again, no matter what you're fuzzing, it's following the same phases. So why not build classes that implement that functionality and then just combine those things for whatever project you're working on? Automated structure identification, I think there's definitely room for improvement there. We're dealing with a lot of proprietary protocols and file formats. It'd be nice if we build some intelligence in there to say, this is where the header is, this is the name value pair in there, so that even though it's proprietary, we can be a little more intelligent in our fuzzing. Fuzzer tracking is really important. Pedram's done some great work in that area. When he shows you PyMate later on this afternoon, you'll get to see some of the work that he's done there. And that's really important because we talked earlier about the inputs. How do you find all the different inputs? Well, if you think you found every input in an application, how can you be sure? Well, by using tracking, you can actually see which pieces of the code were touched when you did your fuzzing, and that way you can know just how complete your efforts were. And again, you'll see PyMate and see some of that later on. And intelligent exception detection processing, rather than just showing me where the crash was, build some intelligence in there to say, yes, this probably is an exploitable and this is one we want to research further, rather than just relying on the researcher's knowledge to be able to do that. Where do I see things going from here? I definitely think we'll see more frameworks emerge, which just seems like a smart approach to me. I would love to see integrated environments. I think the only way you're going to get developers and QA professionals to latch on to things is if you don't ask them to learn yet another tool, but you provide it to them in the environment that they're already comfortable with. So they use an IDE for their development. Build a plugin that's a fuzzer for that particular environment. It's just a higher comfort level of not needing to learn something new. I think we'll definitely see more commercial frameworks. And we're already starting to see that. I know Codenomicon is an example of that. That was started by some of the guys who did the Protos test suites. It's just sort of an indication to me that the industry is maturing. And the people who should be doing this, I definitely think it should be a wider audience, and I think we're going to see that. And the message that I want to leave you with is, be proactive when you're doing your vulnerability discovery. Shift from being on offense to defense. Find these things before your products ever get out into the world. And with that, I'll take some questions. Yeah, go ahead.
You may have answered this, but I wasn't because I didn't see the slide. Can you discover vulnerabilities that are based on timing, like knock-knock protocols? I didn't quite see whether in the strings whether you could put time intervals or some periodicity in there.
That's a great question, and that's a challenge to fuzzing, that if there's sort of other dependencies, it might not just be timing, but it might be I make this request and then I make this request. Yes, you could certainly do it. I mean, the tools that we just demonstrated are pretty basically just fire off a bunch of stuff and see what happens. And typically, when you find vulnerabilities, there's different dependencies or timing issues and things like that. They tend to be found through reverse engineering because it's just harder to find. But there's no reason why you couldn't develop a fuzzer that takes that into account. It says, I'm going to send a packet, then I'm going to wait for this response, and only if I get this response, then I'll send my next fuzz packet. So I think there's room for that kind of intelligence to be built in, but that's a great question.